In this section, I'd like to look a little bit more in depth at how we might use concrete materials to help, not just with the anchor task, but also with the other tasks during the lesson. So, as an example, I've made up this box of some typical resources you might want to use. Inside, you can see a whole range of different things. There are Dean's blocks, so 10s and 1s. There are 2-color counters. These are always very useful. There are square tiles. There are straws for bundling into 10s. This is something that's used extensively in Singapore. There are dice. There are hundreds, 10s and 1s counters. There are all sorts of individual digit counters. There are fractions. These aren't the correct resources necessarily. They're just an example of some you might want to think about having available. I like to have these boxes out available on the table for children, just to save time. The photo on the lid is just an extra touch so they know what's in there. Oh, and the photo on the inside of the lid means you've got half a chance of them being put away properly. Now, thinking back to our stage 1 task, a typical idea might have been to use these Unifix linking cubes. So I might require children to draw their part whole model. And again, it actually isn't important whether the hole is on the left or the right or the top or the bottom. What's important is the relationship. So, one of my favorite ways to do this, as you might see, is just to roll a dice. So 5 is one part, 4 is another part, and altogether that makes 9. And you see, this is a very practical way to do it because children are generating their own numbers. You can make a lot of sentences, depending on the age and stage of the child. You can make a lot of sentences from this. So you might only see one, but I can see about 6 sentences here. So 5 plus 4 equals 9. 4 plus 5 equals 9, because they are worth the same. But also 9 equals 5 plus 4. 9 equals 4 plus 5. But here's the thing. 9 take away 5, the whole take away one part, leaves the other part. So I'm getting so much benefit. 9 minus 5 equals 4. 9 take away 4 equals 5. And again, because this is equal to this, I can say that 4 is equal to 9 take away 5. I can say that 5 is equal to 9 take away 4. Look at that, 8 separate calculations just from this task. Now, I did that without the concrete idea, but if I wanted to do it in a concrete way, let's take a slightly smaller example. So 3 is a part, 1 is a part, and 4 is a whole. Now here's a mistake. Do not, whatever you do, put 4 there. The reason that will be wrong is because now this diagram shows 8. And we're not thinking about 8, we're only thinking about 4. What's very powerful is that children can physically slide the parts to make the whole. Even better, if we have the option, is to use 2 different colors. Because later on, that will allow us to think about parts of a whole as fractions. And that's a very powerful technique. So everything that you see in stage 1 is designed to build towards stage 2. What about this? For children who need an extra challenge? What about that? What about giving them a part whole? Or what about giving them the whole and saying, can you work out what the missing part is? And this is again, the relationship between addition and subtraction. Here, if I know that I have 3 apples, 2 oranges, and some bananas, and I have 9 pieces of fruit altogether, you might be able to work out how many bananas, and what children would do is put 9 in here, put 2 of them to here, 3 of them to here, and discover that there were 4 left. So quite a powerful tool is the part whole model, particularly when combined with concrete resources.